Hey, Miss Smart here. Go over your review for the Unit 7 test, the last test of the year. For that review, you're going to need your calculator. Oops, this way. Your calculator, and then obviously your review packet, and this table will be required for some of the problems. So let's get started. All right, so the first thing we learned in figuring out these proportions was the 68, 95, 99.7 rule. And then we learned about z-scores and how to use the table. So there's times where you use that, one method over the other. So for number one, a battery company is testing their battery's lifetime. Suppose the battery lifetime is normally distributed for large samples. The mean lifetime is 500 days, and the standard deviation is 61 days. Approximately what percentage of batteries have a lifetime longer than 561 days? So here's our mean, standard deviation, and we want to know longer than 561 days. So if we draw this out, our mean is here in the middle, the mean is 500. And with a standard deviation of 61, 561 is just one standard deviation above the mean. And so we want to know longer than 561 days. So from here this way, okay? So let's see here. For this one, I would probably tend to say, okay, from the mean to the very highest battery life is 50% of the data. But this space right here is half of the 68. So this little part to the mean is 34% of the data. And so to answer number one, I would say 50 minus 34 is equal to 16%. Okay, and just a reminder that showing your work on your test is required for full credit. So if you just were like, oh, I've done a problem like this before at 16%, and you had no showing that you understood why it's 16%, you would get at most 2 out of 4. On a 4-point question, you would get 2. That's approaching standard. Yeah, I can figure out, I know the answer, but I don't know how to communicate it. It's not at standard yet. Okay, number 2. A pet store is selling small, medium, and large bags of dog food. The large bags of pet food weights are normally distributed. The mean weights of the bags are 50 pounds. The standard deviation is 0.2 pounds. Okay, so there's some questions to answer. So again, I just want to map this out. So number line, our normal looking curve, the mean of 50 in the middle, and then 3 standard deviations on both sides. So this would be 50.2, 50.4, and 50.6. Going backwards, 49.8, 49.6, and 49.4. Okay. So less than 49.8 pounds. So 49.8 is right here. We want to know this area. Well, this is one standard deviation below the mean and then lower than that. Whereas this one was one standard deviation above the mean and 2 and then greater than that. They're symmetric. So this one's also that 50 minus 34, which is 16%. Between 49.6 and 50, 49.6 is at 2 standard deviations below the mean. 50 is the mean. So we know that within 2 standard deviations of the mean is 95% of the data. So this is just half of that 95 for part B. So 95 divided by 2, 47.5%. Okay. Number 3, determine whether each of the following statements are true or false. A, normal distribution is determined by the mean and standard deviation. That is true. So the mean tells us like where to center it, and the standard deviation tells us like how wide or narrow based on the spread. So A is true. B, the total area under the normal curve is greater than 1. This is false. It's not greater than 1, it's equal to 1. C, within 1 standard deviation of the mean, normal distribution contains about 95% of the area under the curve. This is also false because within 1 standard deviation is 68%. And D, normal distribution is centered at the mean. This is true. That is one of the characteristics of data that is normally distributed. All right, moving on. Number 4, what is the curve for normal distribution called? It's called a bell curve, not a bell pepper. Number 5, a set of data normally distributed has a mean of 120 and a standard deviation of 30. So we're going to label the curve. So here's our mean of 120. Standard deviation is 30. And so add 30, you get 150, 180, 210. Take away 30, you get 90, 60, and 30. What percent of data is greater than 120? Well, 120 is the mean, so greater than that is half the data, or 50%. Between what values would you expect to find 99.7% of the data? So this is going to be within 3 standard deviations, 99.7% of the data. So 3 standard deviations below the mean is 30. And 3 standard deviations above the mean is 210. Approximately what percent of data is between 60 and 150? So 60 is 2 standard deviations below the mean. And so it's half of that 95% that's within 2 standard deviations of the mean. So half of that 95% plus 150 is 1 standard deviation above the mean. It's half of that 68% of data that's within 1 standard deviation of the mean. So I would add those two together. So it ends up 95 divided by 2 is 47.5, and then 68 divided by 2 is 34. And when you add them together, you get 81.5%. Okay, the next question, between 89 and 119. Well, both of those values are not on whole number standard deviations. 89 is right here before 90, and 129 is somewhere between 120 and 150. So we have just over 1 standard deviation below the mean, and then not a whole standard deviation above the mean. So we're going to have to find a z-score for each of those. So the z-score for 89 minus the mean divided by the standard deviation is negative 1.03. We're always going to round this to 2 decimal places. And then 119. Oh, oops, I put that in the wrong spot. That is not right here. It is like here. 119 is less than the mean. I'm a little tired. So 119 minus the standard deviation minus the mean divided by the standard deviation. Okay, So 119 minus 120, and then divided by 30, I got negative 0.03. Okay, so these are the z-scores. So this 89 is 1.03 standard deviations below the mean, and 109 is 0.03, so 300ths of a standard deviation below the mean. So now I go to the table, negative 1.0, and then over to 3. Negative 1.0, there we go, that makes it easier to see. Negative 1.03 is this 0.1515, 0.1515. And then negative 0.03, negative 0.03, this is interesting. That bottom row, negative 0.0, and then over to the 3 column, which is going to land on this is 0, 1, 2, 3. It's right here, 0.4880. Okay, and so we have these two numbers. So the first one, the 0.1515, tells us that below this data point is approximately 15.15% of the data. And then the 0.4880 tells us that below this data point, there's approximately 48.80% of the data. What we're looking for is what's in between, so we have to subtract this piece so that we just get the area right here between those two data points, okay? And so between them, 0.4880 minus 0.1515 is 0.3365. So 33.65% is the final answer on part E. And then finally, approximately what percent of data is greater than 129? So 129 is about right here. I actually was like, saw that number when I was supposed to be doing that number on the previous problem. So mystery solved. So greater than 129. So we're going to have to find the z-score and then the area above it. Okay, so z-score comes first. So 129 minus the mean divided by the standard deviation. So 129 minus 120 is negative 9, and then, or sorry, 9, and then divide by 30 is 0.3. Okay, so I'm going to find 0.3 on the positive side of this table. 0.3 is right here. 0.6179 is the proportion. 0.6179 is the proportion. So what that tells us, if we look back here, if this is our data point of 129, the 0.6179 is the area that way. So I'm going to take it away from 100 because it's asking me on the last question, this area over here, greater than 129. So 1 minus 0.6179 is 0.3821 or 38.21%. Okay, just got a couple more problems here. Here we go. Number 6, a spinner is divided into 3 equal sections labeled A, B, and C. Based on probability, how many times would you expect the spinner to land on C after spinning 30 times? So because it's 3 equal sections, I would expect it to land on each of them the same amount of times. So in 30 times, if there's 3 equal sections, I would expect it to land on C 10 times. Okay, so then after spinning 30 times, the frequency of the outcomes, A is 9, B is 8, and C is 13. Is the number of times the spinner landed on C reasonable? And I would say yes. And I would say it's only 3 more than expected. And then for C, the spinner is spun 3,000 times. Give an example of a number of spins that would result in C that would be possible but unusual. Okay, so I would say I would expect it to land on C 1,000 times, right? 1/3 of the time. So since I expect it to land on C 1/3 of the time, that's 1,000 times. And then, I mean, there's so many values you could choose and say what, that it's possible, but unlikely or unusual. And I would say even just doubling that, with it's possible, but it's unusual. So, I would say 2,000 times is possible, but unusual. Because it is 2 times what's expected. Okay, last set. A distribution is approximately normal with a mean of 50 and a standard deviation of 5. For each interval, state the approximate percentage of data that falls within it. Okay, so one more. You should draw the curve. You should label all the points. There's the mean, it's 50. The standard deviation is 5. So this goes 55, 60, 65. Going backwards, 45, 40, and 35. All right, between 50 and 55, that's half of the 68% interval. So 68 divided by 2 is 34%. Between 45 and 55, that's all of the within one standard deviation of the mean interval. That's the whole 68%. Between 40 and 60, between 40, which is at minus 2 standard deviations, and 60, which is at plus 2 standard deviations, that's at 95%. Between 35 and 65, that's that whole 99.7%. And finally, between 45 and 60. So 45 to 50, 45 to the mean is at 34%, and then the mean up to 60 is half of 95. So it's half of 68 plus half of 95, which we have done, I think it's 81.5. I'm just going to double check. 68 divided by 2 plus 95 divided by 2 is 81.5. 81.5%. All right, that is the end of the review. I hope you found it helpful.